wanted to thank all of the people in attendance, and also wanted to thank those watching on the web live, and for those who will be seeing this later on YouTube and all of the different forums. Now, I encourage people who haven't seen last year's conferences to go onto YouTube and look up the speakers and get a feel for the camaraderie and for the humanitarian effort that's really being put together through the Global Breakthrough Energy Movement. And our next speaker is going to be talking about some things that applies to all of our lives, and this technology can be used to revolutionize and help free us all. So the Global Breakthrough Energy Movement proudly introduces Mr. Goa Loba.
Thanks, Jason. Can you guys hear me okay? Am I coming through? Yep. Okay, cool. So thanks. This is a little double Taurus I printed out as a gift for you guys.
Thank you so much.
So, thank you. Cheers. Well, thank you, Jason, for that introduction, and thank you, Jerome and Robert and all the BEM volunteers who have been so terrific in making this a really fantastic event. Thank you, everyone, thank you, everyone here in the audience for being here and now. And welcome to those of us joining us via the live stream. Thanks for tuning in. And lastly, much gratitude for, again, the Days Inn for accommodating us like this. It's been really great. So before I get started, I just wanted to ground with a quick NLP mandala. This was inspired by or for John F. Kennedy. So I just simply want to say, I'm glad that I'm here. I'm glad that you're here. I know what I know, and I care about you. So again, my name is Goa Loba. And I'm very happy to be here today presenting on 3D printing and what I'd like to call the rise of the multidimensional maker. But before I get further along, I want to introduce you to my good friend and lab partner, Ulti. Ulti is an Ultimaker version 1, a do-it-yourself kit I bought for about $2,000 in late 2011. Now, I really wanted to bring him here today and actually be printing something out while we were talking, but it was a little too much to wrangle for the flight, and so we'll just have some video today. But I did bring a bunch of stuff that I printed, and I'd like to, as gifts for everyone, so if you want something, come see me after. So first I'd like to start with a few questions. Who's never heard of 3D printing? Don't know what it is? No clue. One person, okay, awesome. Okay, who's heard of it, but not really familiar with it? Cool. And then who hasn't had experience with a 3D printer? Great. Does anybody own one? Use one on a regular basis? Whoa, right on. Excellent. Cool. Well, I hope this will be informative for you guys too. So with that in mind today, I'll be trying to cover and expose you to a full spectrum of 3D printing, the different approaches that exist today, the different scales that are at play, the materials that are in use, and what people are doing with it. In parallel, we'll talk about what it means to be a multi-dimensional maker. And I'll show how engaging in 3D printing has inspired me to a completely new way of thinking. We'll also touch on the convergence of social networks, open source projects, crowdfunding, and more, and how all these things begin to compound and synergize to create an expanded consciousness. And finally, I'll share my vision as I peer into the looking glass and paint a picture for you of what I imagine. And along the way, I'd like to share some personal stories and my own personal journey. So I'll start with a little backstory. In 1999, I had a big life-changing experience. I'm a pilot, and I very nearly crashed an airplane. And that brush with mortality made me realize that I needed to make a systemic, if not radical, change in my life. So fortunately, at that time, I was inspired to ask a question I learned from Dr. Bill Voswig, which was, what would you dare to achieve if you knew you would not fail? For me, that answer was starting an animation and visual effects business called Liquid Buddha Studios. Many of you, I hope, have seen the movie Thrive, What on Earth Will It Take? A few people? Cool. I led a small team of animators as the director of visual effects for that film. I spent a full 8 years, and my team put in 18,000 hours on that project. And for those who haven't seen it, I encourage you to go to the website, thrivemovement.com. You can watch it there for free. But if you resonate with it at all, please buy a DVD and join the movement and support the cause. But before I met Foster at the very beginning of my journey, whoops, there we go. I attended a trade show for the visual effects industry called SIGGRAPH. And this marked the start of my journey with 3D printing. At the show, I encountered a machine by the folks at Stratasys, and they were printing out parts with working gears, like the image on screen. Now, these objects seemed impossible to create any other way, and this was my first mind-expanding moment with 3D printing, because I'd never considered something that could create multiple moving parts all at once. Now, at that time in 2000, the industry was fairly new, and the system I witnessed was not printing in color, with only a handful of materials, and priced in literally the hundreds of thousands of dollars. So how does it work? What's going on? Well, simply put, it's a process of first converting a digital model into a series of cross-sections or layers. Then the machine then uses that data to build that up layer by layer. You can see here my Ultimaker starting an iPhone case I designed, inspired for BEM, of course. And at the right are some of the finished products. To be more specific, in this case, I'm using a plastic filament like this, and it's pushed through a chamber where it's heated just beyond the point of melting, and then extruded out this very precise nozzle, and then it cools and hardens in place. Today, there are a variety of materials and a handful of approaches. So let's back up to the beginning of 3D printing. It was all started by a guy named Charles Hall in 1984, who was granted the first patent and also created the first 3D printer and had the first successful print. He called it stereolithography. Sometimes you'll hear it referred to as FDM, or fused deposition modeling, which is what Ulti is doing. Again, transforming a feedstock of, in this case, a colored natural plastic into a three-dimensional object. All of which is covered under the broader term additive manufacturing. So there are dozens of commercial printers available for a few $1,000s. Here at the top is the next generation of the Ultimaker, the Ultimaker 2. The MakerBot 2 is down on the left, which has gotten a lot of press lately. And on the right is 3D Systems Cube printer. Here at the top is an Up style printer, and below is something called the Fabster, which I thought was kind of fun. And this is most likely how many of you, as makers at least, will be experiencing 3D printing directly. Now, the original machines, the ones that Chuck Hall created, used a powdered composite substrate as a feedstock. You can see there at the bottom. And as the machine would spray, a bonding agent through something not unlike a common inkjet printer head, and the powder is swept over the plate as the layers moves up, and they act as like a support structure as it's printed. Now, there are new approaches using different forms of light to bond the powder together, and you may have seen videos like this of someone reaching into a big block of dust, pulling out a printed piece. This is the commercial grade approach. It yields very high resolution, capable of precision working parts, as I mentioned before. Now, one of these new approaches uses lasers, and it's called selective laser sintering, or SLS. The idea here is the same, but instead of extruding something, it uses a laser to solidify either a powdered plastic or a liquid resin. Now, one key here is that with less moving parts, mirrors and lasers instead of motors and gantries, it's much cheaper. And this is also important because a patent on this technology expires next year, and a whole new class of 3D printers will be available to everyone. And I really mean everybody. So shown on the right is one example of an Indiegogo campaign called LumaFold. It's a tiny, foldable unit, which is priced at less than $400. Okay, and this Indiegogo campaign was successful. Okay, and then on the right, an even more extreme example, is something called the Peachy printer. Now, this little beauty uses a novel idea of suspending the resin build layer in salt water. And it uses a drip system to control the height to 1/1000th of an inch. And are you ready for this? It's priced at $100. As you can see here from their screenshot, they've already well surpassed their goal of 50,000 by over 500,000. And there's still time to go. And I forgot to mention it's a scanner too, which we'll talk a little bit more later. Rounding out the different approaches commercially available today is this last type called laminated object manufacturing, or LOM. What's interesting is that it uses regular paper as feedstock, standard A4 sheets. Now, how ironic is that, right? It sprays down a fixing agent along with inkjet color, and finally a robotic cutting head carves out the object, separating the model from the rest of the stock of paper. Now, I took these images at a conference just last month, and this was a brand new device. All these models felt like wood, supple and springy in thin areas, and hard as a stump where it was thick. But I guess that makes sense, being thousands of pieces of laminated paper. Also, it's interesting that the color achieved here is photorealistic, so it leads this industry in that respect. Also, I think there are some very interesting possibilities with this one because, conductive inks are already here, and it seems to me that you could embed conductive pathways with this technology right now. And this one is priced at a mere $45,000. So now let's consider the dimension of scale. Going big, there's something in development called contour crafting, where quick-setting concrete is extruded with a rotating head. And this is promising new ways to construct whole buildings in days instead of months. Now, going small, using lasers, you can achieve amazing amounts of resolution, true nanoscale printing. All of these objects were printed with this a laser, and you can see on the bottom left there, 20 microns across. Now, some of these are smaller than a dust particle, not visible with the naked eye. And when I saw these for the first time, this was another fully mind-expanding moment. Now let's survey the materials available for the maker. For the FDM folks like me, there's ABS and PLA. Now ABS, and I honestly can't pronounce it, acrylyl something butyrylstyrene, is a typical oil-based plastic stuff. Now I prefer to use PLA, or polylactic acid, which is a bioplastic made from corn or dextrose. Now I mention this because as a bioplastic, it's friendly to landfills and composts rather quickly that I've read. And it was good for me to know that there are eco-friendly options out there. As you can see here, there are a variety of colors, but there are also flexible plastics too. And someone has even designed a way to combine sawdust with a polymer so you can print in wood. I thought that was fascinating. On the larger commercial side, you can use a service bureau or spend hundreds of thousands of dollars for one of these printers, but you can use a service bureau to outsource your prints in a wider variety of materials. And here's what's available on one of the largest service bureaus, Shapeways. Again, you've obviously have the plastics. There's also aluminide, which is a plastic-infused aluminum dust, stainless steel, sterling silver, brass, of course, flexible plastic, and they even have gold plate. Also, you can print in ceramics and full-color sandstone. Now, you may be wondering how they're able to achieve full color. Well, in the same way that your inkjet printer uses mixes primary colors, these 3D printers add colored pigments to their fixing agents and using multiple heads, and there you go. Now, the Stratasys folks have taken this a step further. Using the same powdered feedstocks, they've mastered the mixing of different bonding agents to create variations of material properties within a single print. That means within a single print, you can vary the flexibility or stiffness, ductility, or tensile strength of your creation. Now, a simple application would be adding a spongy grip to your printed adjustable wrench or a rubbery tire around a printed stiff axle. We'll put it all together, and what do you get?
Hey, what do you think? That's more like it, right? You're looking at a full-scale printout. This is a full-scale model of a motorcycle that was originally designed in Inventor, and it was made real using a 3D printer by our friends at Stratasys. This is one of the largest, most intricate 3D prints ever made. Talk about experiencing it before it's real, right?
Isn't that amazing? Now, I'm not convinced it actually started on stage. but I do believe it was printed all at once, and it really shows the possibilities. Okay, so you may be now saying, okay, I think I get it. It's not just for rapid prototyping, it's for personal use, it's for professionals in all ages or all sectors, and it's even used to make finished goods. Now let's gain a larger perspective and consider the different parts of the growing ecosystem of additive manufacturing. Specifically, some input technologies and also the social aspect, which I believe has helped drive its growth and evolution. So first, let's start with 3D scanning. This is a technology that combines images and lasers, or sometimes just camera images, to create digital models of the physical object. Now, this empowers a whole new aspect of customization, as you can imagine. If you've been to a dentist recently, you may have experienced them scanning your tooth for a custom implant. Well, that scanning that's already made it to your dentist will soon be at your desktop. Here's an app that enables anyone with a laser pointer to scan an object. The idea is that the laser creates a single slice of the object's profile, which is captured by the camera. Those images are processed, and the projections are combined and finally converted into a 3D model. In this example, part of Autodesk's suite of free tools is Catch, where you use a smartphone to take multiple photos, which are then processed in their own cloud computing system to create a model in 3D. How cool is that? There's also a host of free online modeling tools like SketchUp or Autodesk 123D, further expanding the design tools available to anyone who can connect to the internet. So you can see the parts of the New York skyline in this 3D printed guitar. So what does this all represent? Well, we're seeing the tools and techniques which are shifting the way people are thinking about products, moving radically away from mass production to mass customization. This is the emergence of the digital hardware paradigm. And for me, well, it means I'll probably be printing out my own iPhone cases from now on. Now let's back up a little bit to 2005, where, in my estimation, an amazing thing happened. An open source initiative was started called RepRap. How many have heard of RepRap? Cool. And the goal of the RepRap project was a printer that could print another printer. Okay, so that phrase stopped me in my tracks. A printer to print out another printer. That was another mind-expanding moment. And they've come a very long way. In 2007, the first working design was completed, and now there are thousands of printed printers in existence. In this image on the left is a complete set of printed parts to make one on the right, another one of itself. Just add the circuit boards, rods, and motors, all of these off-the-shelf parts, and presto duplicado. I bring this up because many of the low-cost printers available today grew out of the RepRap project, including my Ultimaker. As you can imagine, this project spun off many design approaches. On the right, you'll actually, the one on the left, if you go out to the exhibition area, there's one of these out near Russ's area. And then on the right side is one of my favorite designs, a Delta printer. And this combines the 3 X and Y and Z axes into a triangular configuration. I was also really excited to see Russ Grease brought his Delta Home printer, which he made himself, so you can check that out if you haven't already. Now, what may not be obvious is that all of these designs can scale up rather easily by simply using longer connecting hardware. Now, here's a home-built Delta printer making ceramics. Now, I think this Delta design approach is a fascinating approach because it holds a lot of potential when we start combining 3D printers into arrays, working in coordination on a single print. So most labs are not complete without a cat, right? Now all of these printers, or not all, but a lot of these printers are running on Arduino. And how many of you know what an Arduino is? Okay, a few. Okay, for those who don't, it's another open source project, a programmable circuit board that can run lights and sensors and motors and more. It's like a maker's Swiss Army knife of PCBs. It's very low cost and very high functional. In fact, my little Ulti is running off an Arduino Mega. Now, the story of Arduino's success is too long to describe here, but its open source nature is one of the primary causes. Now, when I realized that this amazing array of do-it-yourself printers was partially due to the parallel evolution of this other open source project, I started to see the synergy of what was possible with open source. Now, this again was a big consciousness expanding moment because I was witnessing the synergy of open source projects coming together, accelerating the curve for everyone. Now, I'm up to my fourth mind expanding moment here, and I have not even printed my first print. I think I'm starting to glimpse this breakthrough consciousness. So now let's now let's consider the social dimension of 3D printing. Today there are huge portals dedicated to the sharing of models, and in my opinion, this has been a strong force in its popularity. Thingiverse, probably the most popular online sharing site, has over 100,000 models and grows every day, and these are all free. Quite literally, from robots to sneakers to Rodin's the Thinker. Here are all the different categories of free models. You can see art, fashion, gadgets, tools, and more. But to give you a little taste of what's available on Thingiverse, here are just a sample of the planetary gears alone that you can find there. Now, I know many of engineers, this is their favorite type of gear because it requires real precision for them to work. But let's take this a step further. Here's a 3D printed automatic transmission. Now, this particular unit was not printed all at once. It was printed in pieces and then assembled. But think how this applies to education and how rich the process can be made when you are able to explore and create and share ideas old and new. And again, all these examples are available free online and printable with the do-it-yourself and entry-level printers. Okay, maybe one step further. Here's another Thingiverse favorite of mine, a jet engine. Isn't that cool? Want to see it run? So how amazing is that? Now, so far, our tour of Thingiverse has been a little heavy on the mechanical side. So let's change it up. Did you know that museums all over the world are scanning in their collections, sharing them online, thus digitizing cultural heritage? Here's a few examples of the Metropolitan Museum of Art in New York City. For my wife's birthday, in fact, I downloaded a goddess deity statue from 600 AD or something, and printed it out, and she loved it. So how is additive manufacturing being used commercially? Well, to cover all these areas would take a few days by itself, so instead let's take a quick peek at what's happening in medical. Here you can see how customization is so important and helpful. Physicians are able to scan their patient's arm or skull or whatever, and then print the cast or implant specific for that dimension, for that person's dimension. And the medical sector is also a great place to begin talking about what new kinds of materials are now in play. Here we see a number of 3D printed ears. Scientists have also had success in printing bladders, noses, throats, often by culturing the patient's own DNA into a bioprinted material. There's also been success in 3D printed bone, and designs for whole organ printers and 3D printed medicine are in the works. Working with carbon fiber has even inspired NASA to build spider-like printers tasked with building structures in space. We will also see a host of new materials with very interesting properties available to 3D printers. Many of these will be conductive, adding the potential for printed wires and circuits. Here they're using a mixture of gallium and indium alloy, which amazingly remains liquid at room temperature. When the metal makes contact with the air, it develops a thin skin that is strong enough to hold the liquid in place. I'm reading now, inventor Michael Dickey explains, the fact that they are liquid means you could surround them with another material like rubber to make metallic structures that you can stretch and deform. So that took me a while to take in. A printable, conductive metal, which is apparently non-toxic, remains liquid, able to deform. Wow. So we will soon have 3D printing. We will soon have printable wiring. What else is on the horizon? Well, a new dimension of printed intelligence. The folks at PARC have created, they've been pioneering new ways to create these printed electronics and have already created whole libraries of different transistors, sensors, memory, and more. The image on the top is a 3D printed label, which has a power source, a temperature sensor, logic, and a display, which will change, let's say, if the frozen food it's wrapped around rises above 35 degrees. They describe this process as using functional inks, which are combined on the fly, creating a variety of material properties. So where is it going? Well, the price is moving faster than I thought possible. New machines will scale the size of what you can print in both directions, and new conductive materials make way for printed electronics. Okay, so now I'd like to bring the story home for a bit and talk about how 3D printing has impacted me directly, and I'd like to share a few projects that you may find interesting and some stories of my adventures along the way. For starters, I'm sure many of you are familiar with John Bedini and his monopole motor. Well, my goal was to create an Arduino-controlled Bedini with a data logger controlled via the web and all that fun stuff. And here's an optical tachometer I designed to fit the Bedini 3-pole. I literally woke up one morning with the idea for the tachometer. I spent about an hour or so modeling the part, a couple more hours of printing, and by the afternoon, I had it working. What's really fun is that I posted this thing on Thingiverse, and it was made a featured item. And a day later, the folks who actually fab up these kits for Bedini posted on the Thingiverse model saying how excited they were that someone was adding to their design. And I had not expected that. I thought that was really cool. I also made a run at the Perendev magnetic motor, miniaturized one, which I called the Mini P. It never worked, but it was a great project to learn from, combining printed parts with magnets and bearings. And by that point, I had built another robot, another open source project called Shipoko. Have anybody heard of that? Okay, cool. It's essentially a more traditional CNC machine where you put in a piece of material and a rotating head like a Dremel carves out what you need. The acrylic parts in these pictures were created with the Shipoko. I'll also mention that Shipoko was about $600. It's also worth noting that Shipoko itself is built on another open source project called Maker Rails, which might be interesting for you to look up. Now, after my work with Thrive, I naturally wanted to make some Vortex coils, as you can see here. And here you can see the 3D printed toroidal Vortex coil jig I created to wind the magnet wire around. And I must admit that this was partly inspired by Daniel Muniz's work, and after watching some of his videos, I created these jig pieces. And I brought this along to show if anyone's interested. Okay, so now for one of my favorite stories of collaboration and the power of the digital hardware paradigm. Many of you may remember Ralph Ring, who was at last year's BEM conference. I met Ralph soon after Thrive was released, and I got connected with this part of his community. I made a friend there who Skyped me one Saturday morning, and asked if I could print a trunnion, which is this little bracket that holds a Utron in place. You can see them in the blue on the left. Now, they're less than an inch long, and these guys would be very expensive to have milled and difficult due to their variety of angles. Well, I said, sure, I'd love to give it a go. Now, he lives in Australia, and he quickly Skyped with another pod member in London, and then he sent me the file. Within minutes, I was printing out the first of about 40 as we were testing different fill densities for strength, etc. And a couple days later, I was shipping them out. And here's a picture he sent me with the trunnions in place holding the 6 Utrons. Now, I've worked on distributed teams before, but this experience really opened my eyes to the potential of collaboration with 3D printers. It also gave me a new vision of labs spread out throughout the world, yet connected by the internet. And imagine how fast a breakthrough would spread with this kind of manufacturing truly at everyone's fingertips. I can see some nods, you're getting it. However, Ulti has proven to be way more than just a tool in the lab. In fact, if you know me at all, I've probably tried to push an info case on you or given you some other printed gift. For example, at the top of the screen are the Christmas ornaments I gave away last year. Now, I found these on Thingiverse and was able to vary the size for my needs. This model of Chichen Itza being printed on the right was a gift for my neighbor who had just returned from their honeymoon there. Again, a model found online. Supported by an ever-growing library of these copyleft models, it's more fun, much more economical, and a lot more personal than shopping at the mall. And it's art. From creating your own, like this double torus I designed at the bottom, to bringing home a favorite museum piece. It's utility, it's fixing stuff. One of the first things I printed was a bottle opener, which had a very clever design that had a little channel where you slid in a penny to give you that hard edge to pop the bottle. Now imagine replacing or improving on a broken piece of hardware simply because you can scan in the broken piece, digitally mend it, print it, and it's back in service. Now the point here is this. My experience of 3D printing had itself evolved. I'm finding new ways of sharing solutions, considering new approaches I never imagined, all because I exposed myself to this new paradigm of creating and sharing. So now let's consider an entirely new aspect of this machine, in that it evolves. I've witnessed it myself over the last 2 years. Not just that I've printed out parts and upgraded pieces, although that's a mind blower of itself. You can see in this video, the pink and white fan shroud is custom. There are belt tighteners in here, all of which were downloaded from Thingiverse. But I've also made small mods too, from concept to what I call print and play. I mean, how strange is it to expect your toaster to get better at what it does over time? But let me tell you what I mean. Naturally, there have been software upgrades, changes to the firmware, but what I did not expect was that it would unlock hidden capabilities already in the hardware. So let me give you 2 examples. When I first got Ulti, it was quite jerky when it was running at high speeds because the relative speed and weight of the gantry would shake it on the desk. Well, I upgraded the firmware, and the algorithm for the start and stop motions changed. It now eased in and out of the movements, and the vibration was reduced. What's more, when I first got together with Ulti, it didn't know how to retract the filament before making a move. And there would be spiderweb-like plastic that I would have to remove after the print was done. Now, after a new software release, I have retraction. My prints look better and the time for cleanup is greatly reduced. Not only has the software evolved, but I've also upgraded the hardware. For example, the control panel was an upgrade, allowing me to untether the printer from the computer and print directly from an SD card. But most notable was just last month, I added a second print head. So now I'm able to print with 2 different materials at once, not just colors, but materials. So like these larger commercial printers in the same print, I could make a wheels hub with hard, color and plastic, and the outer edge with something more flexible. Now I say all this because, again, these were mind-expanding realizations to me. that my machine would evolve with me over time. That because of its open source nature, if I put in just a little bit of effort, I could make it better, more useful, and more functional. Here's one of my favorite examples. An Ultimaker outfitted with shoulder straps and laptop batteries. And I read he could walk around printing for several hours before he needed to recharge it. Which reminds me, did I tell you that my little Ulti runs at about 55 watts? Of course, that's less than a 100-watt light bulb. So at this part of my journey, I started to take stock in what was happening to me. I started to reflect back on my experience and ponder the expanded reality and the new awareness that I was experiencing. I quickly realized that shortening the loop from imagination to manifestation is a transformational process. What's more, I began to see that 3D printing was part of a larger, multi-dimensional experience. It was more than just taking a digital file and making it real. Okay, that's what I expected. What I didn't expect was these late-night tromps through Thingiverse, having my digital boots muddy with inspiration and rich with details of the road traveled. I didn't expect to be helping others in a global community, accelerating their projects. I didn't expect the evolution of Ulti, and for the impact to be so broad in my life. It was gratifying for sure, but it was also liberating. It was empowering. Beyond that, I started to glimpse how the results compound, how the loop of rapid manifestation would move projects farther and faster than I thought possible. Just like many of the breakthrough energy ideas we've heard about this week, using resonance and geometry to compound the results, I was witnessing the resonance of creativity and collaboration within a larger community, and the resonance within myself of passionate exploration and manifestation. I was now part of this multi-dimensional consciousness, and I started to see how this growing maker community embodied this consciousness. Now, I'd like to share my insights of what's just beyond the horizon in 3D printing. First, the materials will continue to expand for the maker and commercially. I expect recycling feedstock will become practical, and instead of hauling your recycling to the dumpster, you'll stuff it into your own filament maker. And I'm not kidding, I've already seen a Kickstarter project for this. Oh yeah? Right on. If you didn't hear that, Russ apparently has one outside. Further developments of robotics and materials will revolutionize construction and the scales will increase. Not much farther, we will leverage this technology to blend with the essence of nature. I expect biomimicry to emerge as a dominant approach in all scales. With nanoscale tools like laser sintering, we are ripe for a revolution in propulsion. I'm thinking now of Viktor Grabinikov's work and the insect wings he harnessed to make a flying machine. Imagine what the maker community could do exploring that realm of possibility. So now you may see what I see. Social networks of makers and inventors, people of all sectors, will continue to leverage the expanding library of open source projects. I believe a critical mass will be reached, and similar to the rate that 3D printing is penetrating our lives today, we will see a cascade of open energy solutions. As the ecosystem matures, I expect we'll see an opening of systems. For example, the social dimension has already grown to the point where there are now networks dedicated to connecting people who want prints with local 3D printers and artists in their area. We will see more and more companies sharing their designs so that spare parts can be created on demand instead of from digital libraries and not shipped from warehouses full of inventory. As the ecosystem matures, the social dimension will drive more and more innovation, and the rate of change will accelerate. So what's the point? Well, 3D printing is not just democratizing. We've all heard that. But this convergence is liberating. The internet has paved the way and created a framework for open, instant exchange of ideas. Open source has liberated the economics of development. Crowdfunding has liberated the economics of capital. Social networking has liberated marketing. And now we are seeing how 3D printing is liberating manufacturing and distribution. This is convergence. And this convergence that we are all part of is multidimensional living. Now, I don't want to leave you with the notion that 3D printing will solve all our problems. It won't. But what I want you to take away is this, that the 3D printing phenomenon is an archetypal symbol, an outgrowth, a product itself of multidimensional awareness. And as we embrace this aspect within ourselves, we create a new reality where we are liberated by the sharing of ideas, by the opening of projects, and by the expanding awareness of multidimensional living. We are ushering in a new way of relating, sharing, supporting, and energizing. We will experience a tomorrow where even energy is 3D printable. So I leave you with this final message. The more you realize and activate your multidimensional maker, the more you accelerate the journey of creativity, of inspiration, and connection. And finally, toward the realization of our common dream of clean, freely available energy for all. Thank you very much.